Hi guys, John here with Lincoln Industrial. I'm part of the technical support team here to assist you with troubleshooting and repairing our products. In today's video, I'm going to bring you along on a straightforward teardown and rebuild of one of our FlowMaster pumps. On the table is our model 85737 24-volt FlowMaster pump assembly, which is used in our 60-pound bucket pump assemblies for automated lubrication applications. After many hours of operations, these pumps may require regular maintenance to keep them going, hence the need for a rebuild. So without further ado, let's jump into said rebuild.
Before we do, let's go over some tools. On the table are all the tools used today. For the sake of time, we will post a full list in the description below. Some of the notable tools to have are a special toolkit 276-275, crowfoot wrenches, Allen or hex bit sockets, torque wrenches and open-end wrenches, a pipe or strap wrench, a large C-clamp, and some dowels and wood blocks to use as punches, shims, and a handle. Let's also not forget to wear our personal protective equipment. Gloves, steel-toed boots, and eye protection are a must-have for this project.
One unique tool I would recommend having with you is either a camera, even if it is a cheap point and shoot, or your smartphone with a built-in camera if this is allowed in your area. This is so you can document the disassembly and use as a reference while reassembling the unit. As a visual learner myself, I can never have too many pictures or visual reference markers to go by. It is also handy if you have any issues. We in tech love getting photos to view while assisting you so we know what you are seeing and we can respond accordingly. General recommendation is to use hand tools to disassemble these pumps. However, we understand time is money, so you may supplement electronic or pneumatic tools wherever possible. Word of caution though, be careful not to over-torque the bolts. Some of these nuts and bolts have a light torque spec to them, or components could get misaligned if not torqued down properly in place. Because of this, please lightly thread everything down, then finish the tightening process with a torque wrench. With that said, let's get started.
The repair kit we are using today for the 85737 is the 277723. Be sure to check your owner's manual for the correct kit depending on your pump model. Start by removing the dipstick, drain any oil out of the crankcase, then place in a vise. Next, remove the 6 1/4-inch screws holding down the housing cover, then remove the cover and gasket from the top of the housing. To remove the motor on electric units, take a 7/16 wrench to the backside lock nut and drive out the 3/16 socket head cap screws with either an Allen wrench or an impact. With the motor removed from the electric pump setup, the 4 5/16 socket head cap screws can be loosened and removed, along with the gearbox and shaft adapter. If you have a hydraulic pump unit, disassembly starts here as these same bolts hold the hydraulic motor onto the crankcase.
Alright, let's pause here for a second. We may be disassembling the 85737, but now with the drive system removed, we are left with the bare assembly. This is actually the base for all of our current FlowMaster pumps, whether it be electric unit or hydraulic unit. The only difference between these units are the drive system and the tube length. The 3 components, the reciprocating tube, housing tube, and plunger rod, are varying lengths depending on the container designation. The rest of the components are the same.
To remove the pump shaft, flip the pump around in the vise, remove the bearing cover, then using a small pair of snap ring pliers, remove the shaft retaining ring clipped to the end of the shaft. Next, loosen the 2 outlet pin nuts, but do not remove. They will help with keeping the element centered during the removal of the shaft. Lay the pump on its side with the shaft seal facing the table, resting on the tube provided in the special toolkit. Place a shim between the crank rod and the housing, and with the nylon dowel also from the kit, knock out the shaft. With the shaft gone, the outlet pin nuts can be removed, and the pump element freed from the pump housing. We will get to this part in a moment. Remove the shaft seal from the pump housing with a seal puller. Then reposition the pump to access the topmost portion of the pump tube threaded into the housing.
Usually the recommendation on removing a pump tube is to use a strap wrench because it will not ruin the smooth finish necessary for the follower in the bucket to slide on. I, however, never had luck getting one of these to work sufficiently, so a pipe wrench will do. When you use this, make sure you grab as close to the pump housing as possible in order to limit contact the follower may have with any markings that will occur during tube removal. You only need to use this to break the tube loose. The rest of the removal can be done by hand.
Finishing the disassembly of the tube, remove the bronze bushing along with the O-ring and backup washer underneath. Flip to the inlet of the pump tube and take off the spiral retaining ring so the shovel plug can be popped off the bottom of the tube. There is a secondary retaining ring which can remain in place unless it is damaged. Place the tube and components to the side so we can disassemble the element. Remove the crank from the wrist pin anchor by unthreading the 2 pivot pins using a 5/32 Allen wrench or socket. Use a 5/16 by 24 bolt to pull out the wrist pin bushings if they do not pop out themselves. Move to the inlet of the reciprocating tube. with a 3/8 inch hex socket or Allen wrench inserted into the hex slot on the check seat, along with the 3/4 inch open-end wrench on the tube flats. Remove the check seat, ball, and ball cage from the tube. Next, place the wrist pin anchor in a vise in preparation for removing the reciprocating tube. Use a 3/4 inch open-end wrench on the tube flats to break the reciprocating tube loose from the wrist pin anchor. Unthread the tube to reveal the lower plunger and link rod. Using the plunger removal tool out of the tool kit, place the pin in the upper inlet port of the rod and unthread the plunger link rod from the upper plunger. A small screwdriver can be used if the plunger removal tool is not available. However, the tool is necessary for steps later on. Set the wrist pin anchor, upper bushing, and plunger assembly to the side for a moment and remove the lower bushing from the reciprocating tube. I am using a 1/2 inch wooden dowel. Length of this will vary depending on tube length. Insert the dowel into the top of the tube, then lightly tap with a hammer to push out the lower bushing and U-cup. The plunger removal tool is necessary here to unthread the lower plunger from the link rod. Slide the small screwdriver into the upper link rod lubricant port and place the removal tool pin into one of the plunger outlet ports. There is a check rod running through the plunger, so do not try to force the pin all the way through. Unthread the link rod from the plunger to reveal the check rod and spring. Grease will probably hold the check ball in the lower plunger. A small punch may be needed to push it out. Last part of this process is disassembly of the upper portion of the element. Slide the bushing and wrist pin anchor off the plunger. Place the outlet pin in a vise and unthread the upper plunger with a 5/16 open-end wrench. Disassembly of the pump for seal replacement is now complete.
Now I know most of you will not have a pump in as pristine condition as mine. I would recommend at this point taking a few extra minutes to clean off the components as best as you can to reduce the chances of debris damaging the components during reassembly and first startup. Dirt and grime are a major enemy to these pumps' inner workings, so please do what you can to minimize the risk of damage. The pump is now disassembled to the point where we can begin inspecting for wear on the hardware, such as scratches or excessive play, and start the process of swapping the old seals for the new ones in the kit.
Working in reverse order of disassembly, start with the innermost components, which are the outlet pin, wrist pin anchor, and upper bushing and plunger. Note the U-cup on the wrist pin must face down the reciprocating tube, or unit will fail to build pressure and lubricant will enter the crankcase. The rest of this process is to systematically replace seals and retaining rings where needed. I would recommend setting all components out and matching each old part with the new as they are taken off. The upper bushing seen here has a small retaining ring holding the steel backup ring and O-ring in place. Do not forget to replace the O-ring between the upper plunger and outlet pin. Loctite 242 is used on every threaded connection unless otherwise noted. Here we begin the assembly of the outlet pin to the upper plunger. Hand tighten these for now until the next step. Slide the wrist pin anchor, then the upper bushing onto the plunger. Mount the outlet pin in a vise, and with a 5/16 inch crowfoot wrench, torque the upper plunger to between 110 and 125 inch-pounds. The lower plunger is installed to the plunger link rod next, but first replace the plunger check ball and spring off the check rod. Add a small drop of Loctite and firmly tighten the plunger to the link rod. Take the newly assembled link rod and thread it onto the upper plunger. Next component to assemble is the reciprocating tube. Face the tube bottom towards you, lubricate, and install the U-cup so the cup portion faces down the tube. Next, replace the O-ring on the lower bushing, then install the bushing onto the tube. May have to lightly tap it down with a hammer and dowel. Last part to install is the check seat housing after replacing the outer O-ring and the check ball. Place a small amount of grease into the housing to keep the ball cage and ball in place while threading the housing into the tube. If you don't, there's a possibility the cage and ball will fall out during the install to the tube. Thread down and torque the check seat to between 20 and 25 foot-pounds. Reciprocating tube is ready to install on the wrist pin anchor. Reposition the partially assembled element in the vise so the wrist pin anchor is secured in the jaws. Lubricate the seals along with the lower bushing and plunger and upper plunger. Apply Loctite to the wrist pin anchor threads. Then thread down and torque the reciprocating tube to the wrist pin anchor to between 20 and 25 foot-pounds. Pumping element is almost complete. Crank rod must be installed next. Align the crank rod with the threaded bushing slots on the wrist pin anchor. Lubricate and install the bushings. Then Loctite, thread on, and torque the pivot pins to between 110 and 125 inch-pounds. Pumping element is now complete. Place this to the side so we can begin the assembly of the pump housing. Replace the outer O-ring near the tube threads, then drop in the nylon backup washer, and lubricate and slide in the O-ring. Install the bronze bushing, and use this to push the seal down further into the tube. Leave the shovel plug off the tube inlet for now and set the tube to the side. You'll see why in a moment. Move to the housing and check the two bearings pressed into the housing for any wear or unsmooth movement. If they check out, install the shaft seal in front of the larger bearing. Place the housing in a vise, pick up the tube assembly, lubricate the O-ring, and apply Loctite to the threads. Then thread the tube on hand tight. Reposition the pump housing in the vise and install the pumping element. Align the eccentric with the bearings in the housing and slide in the crankshaft. Place a shim in between the crank rod and housing, temporarily install the bearing cover to use as a foot for the C-clamp, then drive the shaft into the housing. This clamp has been modified for this task, but a stack of washers will also work as a flat surface for the normal clamp swivel pad to rest on. Stop when the lip of the shaft is in line with the seal. Remove the bearing cover, install the shaft retaining ring, then reinstall the cover permanently. Before installing the outlet pin nuts, install the new seals. The inner seal and backup washer are probably the most tricky to replace as they are wedged into a small groove on the inside edge of the nut inlet. A combination of picks and a small flathead screwdriver should be enough to manipulate both pieces into place. The order is washer on top, then the O-ring with the nut inlet facing you. Center the outlet pin in the outlet nut ports and thread on the nuts. Torque them down to between 30 and 35 foot-pounds.
Now I'm guessing first thought when tightening the tube to the housing is to crank it down as tight as possible. I'm here to tell you that is not the case. For this pump, the torque spec is between 25 and 35 foot-pounds. There is a specially crafted socket tool used on the pump assembly line to torque these pump tubes to the housing. Problem, I do not have said tool available to me, and we currently do not offer the socket for purchase. You can use a standard pipe wrench, but will end up biting into the metal again and leaving more permanent marks. Let me show you the common way in the field these are tightened without using a pipe wrench, and we'll explain why we left the shovel plug off the tube earlier.
Make a mark on the housing and the tube so you can gauge the amount the tube is turned. Take a 3/8 inch Allen wrench or equivalent size bar, slide it through the tube inlet cage, and slowly twist the tube. Watch the tube marks while tightening. Do not twist past a quarter turn. The shovel plug can now be installed on the tube inlet. We are now on the home stretch with the installation of the drive system. For electronic units, the adapter shaft needs to be installed first, then the gearbox. Hydraulic units will have their shaft directly mounted to the motor. Simply mount the gearbox or motor to the housing, then thread on and tighten down the socket cap screws. Electronic units have the added step of installing the motor to the gearbox. Thread the socket head cap screw in line with the gearbox thread port. Place a lock nut in line with the port and thread the screw home. Tighten both the nut and screw to between 100 and 110 inch-pounds. Fill the crankcase to this line with 10 W30 motor oil. Add a small drop of Loctite into each screw port on the housing top. Set the top gasket in place, then the top cover and thread down the bolts. Install the dipstick, and with that done, the assembly is complete. Before we conclude this video, here's a short look of the pump's operation. The top cover is removed and no oil is in the crankcase for this example. You can see the motion of the crank rod driving the reciprocating tube up and down. When we look at the pump tube inlet, the reciprocating tube inlet travels over the shovel plug. This motion drives the lubricant into the tube to keep the unit primed. If either of these become misaligned, in such a case as over-tightening the tube, the unit will lock up. Hopefully this gives a little insight into how this unit operates.
I hope you found this tutorial helpful. If you have any further questions or troubleshooting concerns, feel free to contact our support team at the information here on the screen. Also, please check the description box below for any further information that will help with today's rebuild. This is John with the technical support team. Thank you for watching and see you next time.